Ready? Okay. Again, welcome to another live from the desk of Lady Ada. I'm Lady Ada, the engineer. We had a vote here about whether I should play more Fallout 4 or do a Class A amplifier for a MEMS microphone. Turns out people wanted me to work on a MEMS microphone amplifier. That's just me and Phil and the cat voting. And I don't want to say who made the deciding vote. So yeah, I got this electric mic, the MEMS microphone, not electric mic, and we have a breakout for it, and I'm going to also premiere Scope Cam, which will be our scope video camera. So I will talk about how I'm going to amplify this, because I want to use this sensor with Circuit Playground, my new dev board I'm working on. And I really like this microphone because it's surface mount, it's easy to pick and place, but it needs an amplifier, and that's kind of what I got to do today to get it from like a couple millivolts out to like a good 2 volts out. So let's get started. Go to the overhead. I also have a little bit of a cold, pardon me. Okay, get this on.
The overhead?
Yeah, can we get on the overhead? No, it's not good.
I didn't even do that yet.
Oh. Alright, that's cool. Hold it up. Okay, so I'm just breadboarding up my Metro, which I will be using as a power supply. And I've got the microphone. I'm going to power it up. Let's see. Some jumper wires. Let's power this from 3 volts and get a nice clean 3 volt power in.
Okay.
Hook up ground. Oh, here you go. Okay. Yeah, I forgot to mention I was going to use the overhead. Pardon me. Okay, ground. And then I'm going to hook up my scope. So first up, you always need a reference ground. And let's get a signal wire here. Oh, this blue wire. Okay. So I'm going to hook this up to the DC out. So this microphone has an output that is that's DC output, and it is basically like about 0.6 volts DC, and then the AC signal on top of that. So Windows works. Okay, so on the scope, I'm going to bring this down. I'm only going to be dealing with positive voltages, and give me maybe like 200 millivolts per division. Okay, so set to 0, and then when I touch the microphone, which basically just kind of gets air in there, you can see that the signal spikes. I can also blow on it, and that'll also give me some signal. But the signal is actually quite small. Like, even if I'm speaking to it quite closely, there is a little bit of motion, but it's like, I don't know, 50 milliamps peak to peak at the most, and I want to have it be a lot more sensitive. So normally what you would do is you would have an op amp, but I'm going to be a total cheapskate with this project, and I want to use just a transistor. And most of it's because of cost. An op amp, you know, you're not going to be able to get going for less than like 50 cents, and a transistor is 2 cents. Can't really beat a transistor. So let's go back to our transistor bin. I should have worn my transistor shirt. Where did I put it? Transistors. Proving to the audience that I'm using a transistor. And let's move this all down a little bit. Just give myself some more room. And let's get a NPN transistor. So I've got my I'm gonna get my classic 3904. I'm gonna actually end up using a MMBT 2222. That's just kind of the classic one that I'm using. But I'll be starting out with I gotta like show every camera, the TO92 NPN transistor. Okay, so I'm gonna put this into the breadboard as well, like that. And then I actually want to basically do what I did before, right? I had a Class A amplifier for the speaker. My magic red pen. Does red pen even work? Yeah, okay. Before I had, I tossed it out, but basically I had, a signal coming in, and then it goes into a transistor, and then I had my speaker, which is kind of like an inductor, actually. And then, you had your flyback diode and all that. But, the signal comes in here, and then it amplifies through the transistor, the small signal, which is coming out of like a microcontroller pin here, which can only drive approximately like 10 milliamps, goes through this thing, which can drive like 200 milliamps. So it's basically just, I was just amplifying the signal strength, how much I could push and pull with, or rather pull with one pin, turning on and off the speaker coil. What I'm doing here is going to be, it's kind of the same. It's going to be a little bit different because it has to be a little bit more precise. Like with the speaker output, you're just blasting signal in. With this, you have a very small, precise signal that you want to amplify. So I have this little signal here, and I want to bring that into my transistor. And first off, well, talk about biasing a little bit later, but basically you have a resistor, and then you can measure the signal here. And the signal here ideally would be about 1.6 volts DC, because it's 3.3 volts divided by 2. And then we'd have maybe like a 1 volt peak to peak signal on top. So I want to amplify this signal, which is like, I think like 10 millivolts or so. I want to multiply this by 100 times gain, which is kind of about what transistor can do. That's within reason. And then I also want to make sure that my DC output, I mean, it doesn't have to be exactly 1.6 volts DC, but I want it to be somewhere around there. I don't want it to be too high or too low, or I get some clipping. So to do that, we're going to take this signal out of the microphone. This is a mic. And then we're going to AC couple it in to a bias. So we give it a nice new DC gain. I mean, the output of this, the DC voltage is variable. So what we want to do is AC couple it into a more stable arrangement. We know that this is going to be 3.3 volt. This is like, it's a solid 3.3 volt regulator. I'm not worried about it moving up and down. It's not nearly as variable as the DC output bias of the MEMS microphone, which does vary a little bit. So you couple in here, and then you have some resistor divider that gives it a light DC offset, and then you have RE, which is your stabilizing resistor to help you set the gain, and then this is sort of like the R pull up, and this is your out. Now I have to remember, like, from 10 years ago, all the math to do this. So I know that I want to have, well, one thing is that it doesn't really matter. The output impedance of the microphone is actually pretty good. I can look it up. So let's just quickly look at the microphone, and I'll just read it off. No, it's just going to take me a second. I just have to remember whether it's like 3 ohms or 15 ohms. The SPW 2430, and then, hold on.
Yeah.
Okay, go to the screen
I'm
technology.
like, what's,
Okay, yeah, I gotta look up the data sheet for this. Sysonic. Okay, so, yeah, so the DC output is about 0.66 volts, but by the way, it's not guaranteed, like that does vary. And the output impedance is 450 ohms. And so basically that DC bias that we have here, we'll go to the overhead, it can vary quite a bit. It doesn't have to be super light. And also the output's going into a microcontroller, which has like 100K input impedance or higher. So like we have a lot of flexibility here. It's not like it's driving some stage where it's like, oh, the impedance is pretty fixed. Okay, so let's remember how to do this. So let's see, I want our pull up. Let's see, 1.6 volts. Let's say I bias this with 1 milliamp, because why not? That seems about right. So our PU should be 1.6 kilo ohms. And then, I don't remember, this DC voltage minus that. What is it, the gain? 1 milliamp bias. I'm gonna have to pull out my art of electronics to want to do this. So VB 0.7 is this divided by RE equals 1 milliamp. And then, oh, I remember, I just want to set the bias voltage to be something reasonable. Let's just set it to also be like about 1 volt. I think that's fine. So let's get another. We have plenty of stickies. So VB equals 1.0 volts. Then RE should equal 1 minus 0.7 divided by 1 milliamp, so R equals 300 ohms. Okay, and that's fine, because they'll just give me a slight drop, and then RPU is going to be, approximately 1.5K. And then I just have to determine how I'm going to set up VB. So VB, I think, is going to be like, this is R1 and R high and RL. I'll just set R high to be 20K and R low to be 10K. And given it's been a while since I've done this, I'm probably off by something, but I'll find out real fast. So I'm gonna grab my resistor bin.
This is what we call dead air in the biz.
No, this is resistor air.
Resistor air?
Yeah. We have a lot of cables here. Okay, I'm back. So, I have my resistor bin full of all my lovely resistors. I'm gonna see if I can get the closest possible values to what I need here. Okay, so I got a 1.5K resistors. That's one thing I wanted. So that's the RPU. Let's see, do I have 300 ohms? Yeah, I have 300 ohms. I vaguely remember that REs for we were about 300 ohms, so I think I did my math right. 300 ohms. And then you need a 10K and a 20K. Those are easier to find. 220 ohm, 2.2K, 47K. I know this is the most exciting part. Watching me dig through resistors. 39 ohm. Mega ohms. I gotta get them more organized. This is one of the things I gotta do. More organized. Resistor party. 7.5K. 120K. 240K. Huh? Oh, is this out of focus? Oh yeah? Okay, lock. Okay. I know. Where's my I'm having a lot of luck finding my 10K resistors. 6.2K, 5.1K. I'll find something. Well, I could go with a 4.7 and a 10K. Maybe that's more. 2.2K. And then... Oh, you know, okay, 47. It's funny, is like tomorrow we're in the store, we're gonna put in like resistor kits, so that'll really help. But today's not tomorrow. Oh, here finally is my 10K. You know what? I can just use two 10Ks. Since I'm not having any luck here. Okay, two 10K it is. Alright. It's cool by me. Alright. So, let's unpower this. Okay, so emitter base collector. So put the emitter resistor in first. So we've got our 300 ohm. And connect that to ground. And then I'll have to set up the power and ground too. Let me do that right now. 3 volt ground and power. Okay, got my rails. Okay, so I got my emitter going. I got to do my our pull up. So, oops. Emitter base collector goes to high voltage, and then I'm going to use my. Oh man, these 10Ks aren't even 10K; they're about 100K. I'm so doomed. I'm gonna be undone by such a tragedy. Okay. Yeah, I'm almost done here. I've got a 4.3K and a 2.2K. It's kind of close. Okay, 4.3K, 2 base, and then a 2.2K also to the base. So let's check out our voltages now. Okay, so on the scope cam, check out our 3 volt line. Oh, this gotta bring this back down to. Yeah, sure. Big scope. Let's do this. Yeah, I was, well, there's so much going on. Okay, so 3 volt line's good. Let me check my base voltage, and then I can actually turn on the measuring. So yeah, 1.1 volts, that's fine. And then my emitter, which is, 420 millivolts, that's fine. And then my collector voltage, which is 1.43. Okay, it's a little lower than the 1.6 volts, but it's fine. It's good enough for government work. Okay, so now I can actually have a party here. So there's actually an AC output from this, and it's 10 microfarads, which is a little bit too big. So I'm gonna grab, see if I have a smaller capacitor. I think I can probably get away with it. 0.1, because my impedance is pretty high here. So from the DC output to here. Okay, and then I'm going to listen in on the collector. Okay. So that's a lot better. So now when I speak into the microphone, I'm getting at least slightly better peaks. Like I'm at 500 millivolts per gradient now. Testing, 1, 2, 3. All right, so that's not too bad. I do want a little more gain. I'm trying to remember. I think the gain has to be. How is the gain set? I don't know my copy of art electronics. I'm just gonna Google for it. So class A gain. No, that's not the system I want. I want the one with the feedback, our feedback. Oh man, I'm gonna have to work this out from first principles. All I can find are books that basically are like, you should know how to do this already because you're a student. Shoot. I should like call up Waz and like ask her. I'm sure she knows this off the top of her head.
We can set it up in the future.
No, I don't want to.
Okay.
That would be.
You can Skype her in.
Waz.
You got a screen?
Um.
No, you got a screen.
Yeah, go to screen because I'm trying to remember how you look this up. But unfortunately, it's all like you should know this because you're studying this as a student. I actually ask Wikipedia. I want to just learn about theory. I can never remember. Was it? What? No, I don't want to learn the hybrid pi. Is it NGT transistor? Here's a look of the transistor beta. It's probably about 100. Well, doing better. All right, I'm gonna look up how to do this, and maybe when we come back next week, or next time, I will have remembered, and we'll actually tune this to give me maybe a gain of like 200. Because I remember it's possible with the emitter resistor. I don't remember the exact math for it. Sound like a plan?
Yeah, you want this?
Yeah, sure. I did half an hour. Now I'm going to read about bias emitter calculators for half an hour, and then next time we come back, I'll have this up in EagleCAD.
Okay, go to Adafruit.com and tell everybody Black Friday sale still going on. Black Friday 15 gets you 15% off in stock. We're broadcasting on 5 networks. We have a lot of stuff going on. Your orders pays for this and keeps us commercial free, ad free, venture capital free, and loan free. Not opposed to all those things. Don't need them now. Would like to keep it that way as long as possible.
Absolutely, and also will help pay for the NyQuil I'm going to need.
Yeah.
All right.
Okay.
Thanks, everybody.
That's it.
I'm
And
going to do some math.